Okay, guys, quickly. Today is going to be a build up from our grade 11 work that we did, and we're going to look at more intense activities because we should do more intense activities than we did in grade 11. And also, we are going to step into our grade 12 content a little bit. Okay, but before we step into that, let us look at how to calculate cost of electricity. That's important. Cost of electricity. Then we look at grade 12 and look at graphs. It used to be grade 12, but it's now brought down to grade 11. Okay. Cost of electricity. And also, I need to look at, can I look at power? Or do I use the question last? Didn't I look at power? We did, right? Okay, but let's just summarize quickly. No, we did. Where we said the unit of power is what? Yeah, we did. Okay, beautiful. And W is energy, measured in what? Joules. We did this. Now, if I were to ask you what 1 watt is, 1 watt, you can just add it to your note, would be what? 1 joule per second. Joule over time. So when you see the word work and energy, means the same. Work and energy literally means the same. Okay. All right, so these are the formulas, and we can just replace P with any of these formulas. All right, so IV, I squared R, and V squared R. So, okay, good. Let's work on cost because we're going to need power to calculate cost. Cost of electricity. Sorry if you have cancelled. Cost of electricity. The cost is calculated per unit used. Per unit used. And 1 unit is 1 kilowatt hour. That is, 1 unit of electricity is power times what? Time. Power times time, which is my energy. But here, the power must be calculated in kilowatts, and time must be calculated in hours. Power must be calculated in kilowatts. Usually when you calculate power, power is conventionally calculated in watts. Then you divide by what? 1,000 to convert to kilowatts. And definitely time is in hours. You must know how to convert time to hours. We must know how to convert time to hours. So the cost now will be unit price. You'll be given that multiplied by number of units used. Unit price multiplied by the number of units. Let's look at 1 or 2 questions on cost quickly. Even in grade 12, they do ask for this cost calculation. But you will be given the unit cost. All you need to do is to calculate the number of units that have been used. And to calculate that, we say power times time. And the power must be in kilowatts. Time must be in hours. That's very, very important. Hence, we call it kilowatt hour. Some of you that buy electricity units or ask your father when they buy, they must show you the SMS they get. You will see it says 18 kilowatt hour. Okay, you'll be able to understand this a lot better. All right, let's have a quick question to look at on this. You know, I like to just get my question papers fresh while you are here, so that you won't say, oh, this guy is giving us grade 1 million work. All right, G, resources, physics. Okay, let's go pick from grade 11. We're looking for costing, paper 1. And today I'm going to also talk about graphs a little bit. You can see it's 3 marks. You know, it's not something that you should kill yourself over. It's something you must just quickly get the marks. 3 marks. The power rating of an electric stove is 1,500 watts. So already I know my power. Power, please, you must know your units. 1,500 watts. If the stove is used for 3 hours, 30 minutes, how do you convert minutes? You divide by 60. How do you convert seconds? Let me put that also. Stop lying. Time conversion. Minutes to hours. What do? That one you're correct. You divide by what? 60. Seconds to hours? 3,600. 60. So from minutes to hours, you divide by 60. Minutes to hours, you divide by 60. So if I have 3 minutes and 30 seconds, how many hours is that? 3 minutes and 30 seconds. How many hours will that be? Anybody? 3 minutes and 30 seconds. I want my time in hours. So the 3 hours is already fine. So what is 30 minutes in hours? 0.5. Because you're saying 30 divided by 60. Thank you, Viwe. So this is what? 3.5 what? Hours. And this one we said you divide by what? 1,000 to give me what? 1.5 what? Kilowatts. Now, calculate how much it will cost to use the stove. If 1 unit, you see 1 unit, 1 kilowatt costs what? 1 rand 15. That's your tariff now. 1 rand 15 cents. So the first thing is to say cost. You can do it in one line. Power times time times unit price. What is our power? 1.5 kilowatts. What is our time? 3.5. And what's the unit price? You can do it in one step there and get an answer. Please give me an answer. Six comma, which is 6 rand and 4 cents. Not bad. Are we okay? Please talk to me if we are all right. Okay, let's get another one quickly. Why are they giving so easy questions? Life is not this easy. Okay, do that for me. Type your answers in once you're done. Please share your answers. £12 30 cents. No, it's 30 30. 3 cents is 03. Yeah, that is £12 30 cents.
Yeah, but
yeah, it's 30. It's 30.
So like I didn't get the zero. It didn't say 2 decimal place.
3,3. Okay, try this. Try this, Nana. 12,30 minus 12,3. It means these values are the same.
Yeah, but what's the point?
The point is, we are talking about money here.
It didn't say 2
No, money is always 2 decimal places. Leave me alone. What is cost? Power times time times what? Unit what? Price. What is our power? I want to do something here. This is, if I leave it like this, it's wrong, right? So I can come here and show that I am dividing. Does that make sense? That's now kilowatt. What is my time? 4 and unit price? 2,05. What did you say answer is? 12 rand and 30 cents. Thank you very much. It's money we're talking about here. Everybody okay with that? Let's do one more. I need to find one where...
feel easy.
Huh?
These ones feel easy.
Because they are. They are. Okay, let's see if we can get... I need one where we have to calculate the power. They are quite easy. Cost is quite straightforward. No stories there. Okay, there we go. Then I think after this I'm going to quickly look at graphs. Let's put a time frame of 3 minutes. Everyone should be done in 3.
very medium, like I need to keep also just doing past because for like
Do you guys want to share answers with me quickly? What are your answers? Answers, please. All right, you said your answer is again 4 rand. 4 rand? I'm seeing 4 rand 51 there. Quite, yeah. And why do you have 1 rand 28? It cannot be 1 rand 28. I don't think so. The potential difference of a household. Okay, good. This one is you need to calculate power. I love this one. Okay, let's check. The potential difference of a household is that. So V is 220 volts. A girl uses a hairdryer that allows maximum current. Beautiful. They're giving us I of what? 16 amps. To pass through when it is connected to the power source. Calculate how much she will use for electricity. Time is 30 minutes. We have a problem. And our unit cost is what? 2 rand 56. The first thing is to say, okay, power times time times what? Unit. But do you know I don't have power? Now, what is the formula for power? We did that last week. P equals to what? IV. So, IV. But can I put over 1,000? Why? I am converting to kilowatts. All right? Times my time times my unit. What is my current? 16. 220. That's power in watts. But converting to kilowatt, 1,000. What about time? 30 minutes over what? 60. Converting to hours. And then what do I have? 2 rand 56. Put this in a calculator. Let's confirm. You forgot the 2. So you put 56 cents. Wow. Good South African citizen. I'll tell Ramaphosa to make you Minister of Electricity. 30 over 60 times 2,56. 4,51. 4 rand 51. This is how much you are charging when you use your hair dryer. 4 rand 51 cents. Are we okay? Are we okay? Those of you that got it wrong, are we okay? Can I look for one more? I hope we would find something more challenging than not just very straightforward. I don't like those straightforward things. Then you feel that life is very simple like that. Let's see 2019. Oh, we did 2022 already. Okay, let's see 2019. I just like to do a lot of questions. From here, guys, I'm going to do a graph question. Okay. Cost of the 2,000 watts. No, please, we're more than this now. But did we do this question? No. No, this one is straightforward, please. We are given power as 2,000. We are given 5 hours. No, this is for grade 8. Yes. This is grade 8 electric circuits. Let's find something else. 2017. I want something with a bit of vavavoom, you know? After this, I want us to answer multiple choice questions as well. Most of the time, learners will run away from multiple choice and then we start facing fire. Come. Okay, this is moving too fast for me. Let's see. Oh, this is beautiful. There we go. 6 minutes, 6 marks. Don't forget your power formulas. But they give us power here. They give us power already. 6 marks. I'm sure we can do this in 4 minutes. Huh? What?
What's energy?
Calculate the energy used. Energy is W. You have power equals to W over delta T. Remember, we said this is work or energy. So you'd find some, you can also write it like this, E over delta T. Okay, guys, let's shoot. Sorry? No, we only say over 1,000 when you're calculating cost. If we are done, we don't have to wait for the entire time. Just type in done. I may not see your thumbs up. Just type done, done, done. I'm just going to check against the number of people in class. Once you are done, just say done. Okay, I only see 3 people telling me they are done. What's going on there, people? I'm only seeing 3 done. I need more people done. Okay, let's mark. What do we know? A geyser label 2000 watts, that gives me my power rating, is used for an average of 5 hours. Cost is 80 cents per kilowatt hour. Can you see kilowatt hour? All right. Calculate the energy. Energy is something as work. So I could say P equals to W, or I could use E over what? Delta T. I want to see if you guys got this right. What is the power? So E, energy or work, is power times what? Time. What's our power? 2000. Remember, I am not looking for the unit, I'm just looking for energy. What about time? I have to convert that back to seconds. The only time I work with hours is when I'm looking for costing. So what's your answer here? I know most of you did not multiply by 3,600. So take note of when. 2? Never.
Multiplying.
Yeah, 2,000 watts times 5 times 3,600, because time is in seconds. 3? Okay, change it to scientific notation. 2,000
0.036 times 10 to the power 9.
3,6 times 10 to the power 7. Shift mode 7, 3. 3,6 times 10 to the power 7. And joules of energy. Please, let's take note of the units. Let's take note of the units. That's very... What do you have?
0.036 times 10 to the power 9.
But when we say standard form, it must be 1 number and 2 decimal places. Now, the examiner wants us to calculate what? What are we looking for now? Cost. Oh, what is cost? We know it's power times time. But now, my power has to be in what? Kilowatt. And my time will remain that. So what will that be? 1,5 times 5 times 0,8. 6. What did you got? You said you got what?
No, but the 9 is wrong. Is it?
No. Oh, no, wait. Hold on. They said calculate the cost of operating the geyser for a month.
Yeah. So times 30.
This is 5 hours per day. Hold on. What am I missing? 5 hours. I have to multiply by 30. Yes, Michelle?
So, why is it 1,500 instead of 2,000?
Sorry?
Why is it 1,500 instead of 2,000?
Oh, sorry. 2,000 here. I think the other question was in my head. 2,000 converted to kilowatt, that's divided by that. Time is 5 hours for 1 day, but we have 30 days, right? And the unit is that. So what will this give us? 240 rand. Are we okay, guys? Are we on the same page? So please take note of when to convert and when not to convert. Very, very essential when to convert and when not to convert. All right, beautiful. So we can say, guys, we are kind of done with grade 11 work, but I want us to look at some applications. And in terms of applications, we're going to pick a graph question and a multiple choice question. All right, that's our next topic there. Let's quickly run. If we can answer maybe 4 multiple choice. Oh, beautiful. There's one here. This multiple choice will test if you really understand circuits. There we go, everybody. 2 marks. And while doing this, we'll be explaining some beautiful concepts. Please don't guess. Don't start guessing. Some of you already have an answer. You haven't even read the question. 4 minutes, because you have to reason. Okay, let's see. A, B, C, D. Come, talk to me. A, B, C, D. What is your answer? We are looking for the reading on V3. We are looking for the reading on V3. You said what?
I think half of V4 is there. I mean, of V1.
Half of V1.
Is it there?
Okay, there's half of V1 there. But are you sure?
Yeah, like,
That's what you think?
yeah, because
Yeah.
because they, my,
Yeah. Guys, please share answers with me. Okay, you want to use all the 30 seconds to now finally guess. For the first 3 minutes, no answer. The remaining 30 seconds is now to guess.
current was split between this way and this way.
If it's parallel, current splits.
Yeah. So then, but then this one here is resistance is like high, right?
still going with your answer? No, I'm just asking. I don't even know what the answer is. Okay, guys, let's analyze. In the circuit diagram below, the battery has a negligible internal resistance. We are actually going to start looking at internal resistance. The resistance of the ammeters and wires can be ignored. All right. Now, this is what I like to do. I like to find out how current is moving. Current will always move from the positive to the what? Negative. So current comes this way. When current gets to this point, what happens? It will divide. It splits. And because it splits, we know that is a parallel what? Connection. And we know that parallel are, you see, current what? Dividers. Current is divided. Okay. So there's a current that goes through here. This current that goes through here. Now, if current goes, let's call this I1. Okay. And let's call this I2. The current that goes through here is the same current that will go through. So we have I2 going here, I2 also, because they are connected in what? In series, and then it combines and we have total there. But we're not looking at current, we're looking at potential what? Difference. Because this and look, let me break it down for you. So I have my 4 ohms resistor and I have my other parallel connection 8816. Because they are connected in parallel, what happens? V here will be equal to the same V there. But hold on, it's a very tricky one, but that's the first step. Parallel are current what? Dividers. So the potential difference remains what? Let me use numbers for you. Although we don't have numbers here, if this is 8 volts, this will also be what? 8 volts. Okay. But if you look at this part, what do you notice? It's in series. So my 16 ohms, let's break it down again into what? Series connection. So current requires analysis. Because they are in series, series are potential what? Dividers. So the entire potential difference that I have across here is V1. Because V1 on top, V1 at the bottom. But because they are connected in series, what happens? They divide the potential what? Difference. And they have the same what? Resistance. It means the potential difference will also be equally what? Divided. So this is V1 over 2, V1 over 2, which is half V1. And the correct answer is B. Please let me know if it makes sense to you. Please. Very, very important that we understand the dynamics of current. Multiple choice. This thing can be very brutal. Please talk to me. May I please get response? Huh?
I would not have said that in my paper.
Oh,
I'm trying to rush and get through. It's like put on this.
no. It's very, very important. We don't. The explanation is very, very important. That's why multiple choice will test. Do you really understand what we discussed in terms of content? Okay, beautiful guys. You can take a picture of this if you want, just to see the explanation. Somebody can take a picture and send on a group so that people can make reference. So I like using my acronyms. It works for me all the time. Series are parallel dividers, parallel are current dividers. All I need to do is to trace how current is moving. Thank you so much, Tehfatu. Okay, let's get another one. I just want to make sure our knowledge of circuit is solid before we start adding other stuff. What is this? Newton's laws. Okay. Oh, there we go. 3 minutes. All right, share answers with me. Share answers with me. Yes, Michelle?
So quickly before I share my answer, please may I ask, what does this E represent? Does it represent like the voltage?
Yeah, it represents, it's like the voltage. We'll be looking at that EMF shortly, but it's basically the voltage.
Oh, okay. Thank you, sir.
So share your answer now. in the circuit diagram below, battery of an EMF, I'll be looking at EMF now quickly. According to the exam guideline, we are supposed to look at EMF with you in grade 11. But it's good to first see what this whole thing is all about, because we're just going to apply all of this now when we get to EMF. Okay. EMF and negligible internal resistance is the two resistance. The resistance of one is double, okay, R and 2R. The current in the circuit is I, which is the total current. Total current. So current comes here is I, which is divide. When it gets here, it what? Divides. Okay. What are we looking for? What are the readings on the ammeter and the voltmeter? Look, the first thing we realize is parallel connection, right? What do we know? Parallel are current dividers. Series are potential. So if they are in parallel, current is divided, but potential difference remains what? The same. It's either this or that. Potential difference on top is the same as potential difference at the bottom. Ammeter reading, what do we do? Which one is going to have more current? The higher the resistance, the lower the current. But how do we work that out? Let me show you something that might help you. It's called ratios. So I have 2R and R. I want you to listen to this, because these are what? Inversely proportional. So what's my total? My total is what? There are two ways. I'm going to try to quickly use the two ways, 3R, and see if we get the same answer. 3R. But I want to divide it. Because they are inverse, I'm going to swap it. Current, so we want to divide I in the ratio of 1:2. But for this one, I'll be using 1. 1/3 times I. And for this one, I'll be using what? 2/3 times I. Because I am switching them. They are inversely what? Proportional. So what is the reading on the voltmeter? For 2R is what? 1/3. So the correct answer is B. Please take note, they are inversely what? Proportional. That's why I am switching. The one, look, it's even, what is this? This is 0,3I. What is this? 0,67I. You can see the one with lower resistance has the higher what? Current. Yes, talk to me. Yeah.
So, can you please explain?
Okay, beautiful. So it's about ratios. Like I said, let me try to do something first for you guys. Okay. What is the total resistance in the circuit? Since it's parallel, we can say product over what? Sum. Right? Which is what? Product 2R times R over 2R plus R. I want to show you something. And what would this be? 2/3R, mathematics. Lovely. That's my total what? Resistance. R total. Okay. And what is V? V total is I total multiplied by what? R total. So the V total will be I total. What's my R total? 2/3R. Are you with me there? Okay. Now, how do I get the current? Usually we'll say current is what? V over what? R. The current in the 2R, let's deal with the 2R. We don't know the current in the 2R. What is my voltage? I total multiplied by what? 2/3R divided by what? What's my R? 2R. This R will cancel the R. What is 2/3 divided by 2? 1/3. You can check on your calculator. Can you see that I come back to my answer? This is me using calculations. Let me take you through the calculations again. First thing was I found my total resistance. I hope that makes sense. 2 over 3R. You let me know where you lost. But V total is I total multiplied by what? R total. V total therefore is I total 2 over 3 times R from there. Now the question is asking me for current. So I is V over what? R. Now for the 2R resistor, I is V. Remember the V there, we said the V up here is the same V over there. Over the value of the R. But what's my R for 2R? 2R. The R's will cancel. 2 over 3 divided by 2 would give you 1. So it's 1 over 3R. If I want to go back to what I did using what? Ratios, which is shorter. Check here. Using ratios. Don't forget this. R and I are inversely what? Proportional. So I have 2R and R. When I is coming here, it is divided in the ratio 2 to 1. So we want to divide I in the ratio 2 to 1. We go back to grade 8. What do we do first? We find the total ratio. And it is what? 3R. Okay? Now, for 2R, normally I should have said 2 over 3 multiplied by R. But because they are inversely proportional, I'll have to swap the values. For the 2, I'll use the 1. And for the 1, I'll use the 2. Because of this relationship. If they were direct, I would have just used 2 over 3 for 2R and 1 over 3. But because they are inverse, the one with more resistance will have lower current. Did that make sense now? I don't know if I was able to use ratios and that other calculation. Guys, this is what will test whether you know a content of any subject. Okay. All right, we'll do more of this and do more multiple choice, but let's quickly run to EMF, internal resistance and EMF content now again. So you've seen what content will do to multiple choice. So please, let's focus on this now. EMF and internal resistance. Let's start. We defined EMF in our first lesson. EMF, symbol is E. It is the maximum energy supplied by a cell per unit charge that passes through it. Please, I want you to get the dynamics. It's going to be very simple. That passes through it. Again, I did mention this. EMF is measured when no current is flowing. When no current is flowing. That means I is equal to what? 0. When no current is flowing, we measure the maximum. Okay. A battery has an internal resistance. We did our definitions last week. That is opposition to the flow of current within the cell. When I say cell, I'm talking about one. When I say battery, I'm talking about many. A battery has an internal resistance. And what is internal resistance? Resist means to oppose, opposition to the flow. And this is what we are going to be looking at. R and R. This is now my cell. This is my internal resistance. And this is my external resistance. While you're drawing, let's create an open switch. Here we are measuring EMF because the switch is opened. So this is the whole diagram. Now is to look at the dynamics of operation. So this whole thing is my cell, that's my internal resistance, and that's my external resistance. And because the switch is opened, I'll be measuring, let me put voltmeter there, but I'll be measuring what? EMF. The maximum energy that the battery can supply. Maximum energy that the battery can supply. The R, small r, and the R are connected in series. They are never connected in parallel. They are connected in series. What do you have? If you have? You just, yeah, it's fine. Because my single block there means I've done all my connections and made it one resistor. So all your externals will never be connected in parallel to the internal. They are all connected in what? So you add them up together, it gives you the total resistance external, and that is connected in series always. All right, is connected in series. Let's put always there. Simple, straightforward. And if they are connected in series, yes, talk to me, Michelle.
Yes, sir. Please may I ask? Please may you repeat why they can't be connected in parallel?
Why?
They cannot be connected in parallel.
There is no way you are going to, in fact, it's not possible. How would, because the battery is the one supplying the energy and everything is connected to the battery. So only external resistors you can play with external, you don't have a choice. For you to connect this, you have to go inside the battery now and do this. And you cannot go inside the battery.
Oh, okay.
Makes sense? All
Yes,
right.
sir. Thank you very much.
Good. And because they are connected in series, what happens? Do you remember our acronym? Series are potential what? Dividers. It means the current in R is equal to the current in R. The current, because the current is coming from the battery, right? So the current that flows in the internal resistance would be the same because they are connected in series.
So I added here to find my current.
No, you don't add. If it's the same, you don't add.
But then, how is
If
this?
it's, again, why is it the same? They are connected in series. If they are connected in series, what is, let's go back to current. Current is what? The rate of flow. So they are flowing at the same rate. That's what we're saying. But the potential difference is different. Why? I explained that last week. Potential difference is the amount of work that is done. because my external is higher than my internal is always small. It means more work is done outside than inside. I'm going to do an explanation to you that might help you see what we are going to do here. I want you to consider a pregnant woman. One thing about a pregnant woman is they eat more than normal. Why do they eat more than normal? They're eating for two, maybe three, okay, or more. So check this. If I buy a can of Coke, let's buy a can of Coke. I want you to see something here. I buy a can of Coke. It always it has energy rating. So let's say 40 kilojoules per whatever it is. It means this can of Coke cannot supply more than this. This is the maximum. So this is my what? EMF. A mother then drinks this. Do you think the mother is going to enjoy the whole 40? No. There is that little baby and mommy. Where's the baby? In. And here's the mother. So the mother will probably enjoy 38. Why? She has more energy. She has more work to do. That baby is just sleeping. There's nothing. Swimming and sleeping. Oh, 3. Swimming, sleeping, kicking. Swimming, sleeping. That's all they do. So they don't need much energy. What do you notice? The addition would give me that 40. I want to use a language. Can I say the mother has lost 2 kg to the baby? 2 kilojoules. Yeah, because she didn't get to use it. So we usually call this the lost volt. I used this word last week. Or internal voltage. Lost because of internal what? Resistance. Guys, I'm going to bring this back to science for you now. All right? I'm going to bring it back to science. And this one is what? Voltage what? External. So this is what is happening scientifically. This is just to help you see. Scientifically, please, I want you to see what's happening. I want you to see what's happening. I'm praying you understand this. I'm going to use what I did last week to make you see what's going on. What's going on here? Charges are moving, right? Okay, so a charge, a full charge wants to move out. Let's call this a 9 volts battery. That's the maximum. So this thing is full. It's 9 joules per coulomb. When it gets here, it's going to experience a bit of what? Resistance. What is resistance? Opposition. So this guy has to do work to move over that. By the time it comes out, it has lost a bit. So when it comes out, it's no longer full. Let's call it 8,5. It now has 8,5 joules of energy. What has it lost? 0,5. Oh, so we have lost what? 0,5 volts to the internal what? Resistance. Now, that is going to come here, and what do I have here now? I have my 8, what? 5. I want to tell you why current will be the same. And then here, I'll have 0, and then it goes back in and refuels. Why is current the same? Current is the rate. It's the same speed. The rate at which current is flowing. These things are flowing. It's moving. Same speed. That's why current is the same. But do you notice potential difference is different? That means, please let me know if this would then make sense to you to say, how would I have calculated the total in the woman of the coke? It is the addition of the two. Hence, check this, my good learners. EMF is V external plus V what? Internal. This is the maximum. That's the external in the mother, and that's the internal what? Resistance in the baby. The 38 plus the 2 would give me the 40. Smart. But the current is the same. Oh, what is V from Ohm's law? I multiplied by what? R. But the current is the same. I multiplied by small r. Now what's common? What do you have? And we are done. That's grade 12. And this formula can be best written again as, this is very important, IR plus V what? Internal. Guys, did this make sense? So whenever we have internal resistance, we lose power. Just continually think of internal resistance as the little baby. So the mother doesn't get to enjoy the full maximum capacity that coke can give. Please, did this make sense? But when the switch is opened, we are going to measure what? EMF. When the switch is opened, we are going to measure what? EMF. Immediately we close the switch. I want to explain something. Please let me know if you are done with this page. But the formula will be given anyway. So, formula will be given. Just understand the split. Now, this is what happens quickly, guys. If I have, I'll do a demonstration now. When the switch is opened, let's put that note down. When the switch is opened, that is no current flowing, you got to look at the switch. Let me be careful. Don't let me just say when the switch. When the main switch is open, no current flows. We measure EMF across the battery. And I'm going to be doing some measurements across different points now. When the switch is closed, the reading on the voltmeter drops. The new reading is the V external. We calculate V lost. Remember, the word for V lost can also be what? V internal, by saying E minus V what? External. So we'll be switching between V lost and V internal. You know, even I switch a lot, but just know that it is the same thing. So when the switch is opened, we measure EMF, but immediately we close the switch, then things change. And this is the grade 12 part. We're just going to look at applications and questions, and then we'll deal with graphs. Let's look at questions today, and we'll deal with graphs later. So you've got to read the question very carefully. They'll tell you with internal resistance, without internal resistance. You must know all the ones we've been doing, they were without what? Internal resistance. Guys, please let me know if you think you understand what I just said. If you're lost, let me re-explain before we look at a question. Every other thing remains the same. It's just this addition, that's all. But every other thing, series are still potential dividers, parallel are current dividers. Every other thing remains the same. Voltmeter connected parallel, ammeter connected in series. That does not change. For me, I might call it a Saturday. Yes?
Sorry, sir, I will be done. Please quickly go back.
Okay. Let me know once you're done. Okay, let's go fetch. So guys, officially welcome to a grade 12. Let's play 2018. Let's see 2018. Let's just have some fun. Officially, I think grade 12s are writing this in term 3. Oh, beautiful. Beautiful. You will quickly see what I mean by internal resistance. 5 marks here. Look at this question. In the diagram below, a battery with what? EMF of 6 and an internal. How do I know it has internal? Can you see the dotted lines? That's my battery. Why is this called a battery? There are 2 cells there. And do you see this is inside? Make sense? The current flowing through, okay, come, let's quickly walk through. Current would come here, right? And what happens? It will split. So we're going to have, let's call it I1 and I2. When they get here, what happens? They combine back and I have that current. So the I that flows here, I1, I2 is the one flowing here. It comes here, it comes here, it comes here. It's going to flow through this. It's the same I. That same I will be the one flowing through this. Once you understand that dynamics, we're good. All right? We have 3 resistors PQR. A voltmeter V is connected across the battery. The ammeter has negligible resistance. My good learners, calculate the ammeter reading. Wait, let's make a list of what we have. This one, it's like I picked a very good introductory example. Do I have EMF? 6. Do I have my small r? What is my small r? 2. I am looking for I. What is that formula? E equals to I into bracket R plus R. What is this R? Total what? External resistance. Guys, look at this circuit. Can you calculate the total external for me? That's grade 10. Everybody, let's calculate total resistance. Total R external. This is, I was guided to a good example here. I couldn't have picked anything better. total external. You have, don't forget there are 3 of them, so you need to know what to do. Throw in your answers for me once you are done. I'm not asking you to calculate everything, but you can, once you get that total R, you can actually calculate everything now. Because you just substitute back into that equation. But the first duty is to get R total. Huh? Weird answer. 1/3, that's 0.33. It's fine. But I don't know if you're correct. What's your total resistance? Anybody? What did you get for total resistance? Okay, then we're done. I see Tejo also give me 16, Michelle giving me 16. Good. Do you notice that these two are in what? Parallel, right? So I can say R parallel is what? Product over sum. What's the product? 10 times 15 over 10. Oh, this gives you 6. 150 over 25, 6. Now, R series, therefore, is what? R1 plus R2, 10 plus 6, which is what? 16 ohms. Now, I know my formula. E equals to I into bracket R plus R. 6. What is my total? 16 plus. You think it's weird? What do you mean it's not a proper number? Sorry guys, just want to show this child something. Here's the memo. No, but I want your confidence to grow. It's question, what, 9, I think? No, I just like to do this sometimes. So as you'll also trust the process. It's important. Once you build confidence, then it's important. There we go. Because of your glasses that is not here, let me make it big enough. Can you see? 0.33 amps. Guys, does this make sense? Let me know. Such a beautiful introductory example. I just love it. It just works perfectly. E equals to I into R plus R. Okay. There's a follow-up question. Let's see the follow-up question. Okay. The switch S is now open. Oh, no more calculation, theory. It's just theory now. Let me do this. It's now theory. The switch S is now open. Okay, I want to reduce this diagram. Come. There we go. Let's try to reason now. The switch S is now open. Okay, where's S? All right, when we open S, what do you think will happen? The 15, no, there's current. You need to watch where the switch is. That's why I wrote the main switch. When that is opened, current will come this way, right? Current will come this way. And just go this way now. Make sense? Okay. So the 15 is no longer in operation. Will the ammeter reading in, I did this last week. My good learners, please, I want to give you one important answer. Please, okay, calculation we spoke about, we're okay there. Before we jump into this, please, I want to quickly give you a small note on the theory. Good. Behavior of internal resistance. Let's quickly do that. The behavior of internal resistance in relation to voltage, current, and resistance. The acronym I love to use. So I use two acronyms in grade 12, SAP, DPA, ID, that I consider as one. Then I use what I call revive. I want you to see how I'm writing my revive. Where the R stands for what? Total resistance. Where the I stands for what? Total current. Where the VI stands for what? Voltage what? Internal. And that voltage internal is also known as my V what? Lost. Because it's inside. And what is this called? Voltage what? External. Guys, I want us to look at the relationship with this. With total resistance increasing, if total resistance increases, let's put the word if. If total resistance increases, and there are a lot of factors that can cause that, which we did last week. We can add a resistor in series, or we can remove a resistor in parallel. Those are two things. Oh no, there are three of them. Add a resistor in series, remove a resistor in parallel, or increase the value of one of the resistors. Total resistance will increase. What is the relationship between R and I? R is inversely proportional to I. So what happens? The total current does what? Decreases. The total current. You don't need to cram it. I'm just going to use the law that you know. But V lost, V internal equals to IR, which means V is directly proportional to I. So if my current decreases, what happens to my voltage? My internal voltage will also what? Decrease. So V internal will what? Decrease. Please, I want you to see I'm using relationships. Number one, if my total resistance increases, the relationship between resistance and current is that they are inversely what? Proportional. My current will decrease. But look at this formula, everybody. Look at how do I calculate my V lost? I multiply by small r. So if I is decreasing, this one is remaining constant, R is constant. What will happen here? Decrease. Okay. And the last point, number 4. The EMF is constant. The EMF will not change. Therefore, V external will increase. Go back to the idea of the baby. The baby is now full. The baby, instead of taking 2 joules of energy, the baby takes less. It means the mother enjoys more. If the baby takes more, the mother enjoys what? Less. Because the 40 joules of energy is constant. This is 4 marks. And should I change all these values, what's going to happen? Let me use green. If total resistance decreases, what's going to happen to total current? It will increase. If total current increase, V lost will what? Increase. And V external will decrease. The first and the last one, check. They are always the same. Revive. If this increases, this will decrease, and that will increase. That's what we're saying. And if this one decreases, inverse, direct, is constant. Beautiful. I wish my grade 12s were here, then I know I'm done. One time. Huh? Just 12. 1.5 hours. Guys, are we okay with this explanation? So your job is to watch what's going to happen to R, and then the rest would follow. Remember, for R to increase, we can either add a resistor in series, remove a resistor. Do you want us to add that note to it? We have it already. It's there, last week's note. For R to increase, we add a resistor in series. But let's just add it. Are we okay? Are we done on this page? I want to add that note to it just to simplify it. Are we done with this page? Okay, let's just add it. Total resistance will increase when? Number 1, when you add a resistor in series. Number 2, remove a resistor in parallel. And number 3, increase the value of a resistor, or increase the resistance. And total R will decrease. Number 1, when you do what? Add a resistor in parallel. Number 2, remove a resistor in series. And number 3, decrease the value of a resistor, whether in series or parallel. Same thing here, whether it's in series or in parallel. I like to give these notes so that you can read on your own and, prepare for exam time. You just go through the note, bullet forms. Remember the little concepts. Okay, let's see if we can finish that question. But are we okay so far, guys? Are we okay? This is the content that's just been added to grade 11, I think, from last year. Otherwise, we're not going to look at that all, but it's been dropped from grade 12 to grade 11. That means in grade 12, we just repeat the same thing. And there's still more though. I need to draw graphs for you just to, it's still the same concept, but we then use graphs. We're going to turn this into graphs. Okay, can we try to answer the remaining part in the next few minutes that we have? The switch is now open. What happens? The 15 ohms is removed. It means 15 ohms is removed. Wait, how is the 15 ohms connected? In parallel to the 10. And you can test it. Wait, do you remember we got 6 earlier? No, what did we have? 16. Now, if we remove the 15, what happens? We have the 10, which is now in series with the 10. So my total resistance is now what? 20 ohms. Does that make, can you see? Removing a resistor in series, in parallel, will increase. Okay. Will the ammeter reading increase or decrease? Very simple. We have already said what? 9.2.2. What did we say already? Total R. Total R does what? Is increasing, right? Therefore, total I will what? Decrease. Why? R is inversely proportional to I. I'm done. How will the voltmeter reading, I want to show you something beautiful. How will the voltmeter reading now compare when the switch is closed? Look, it's 1 mark plus 3 marks. How many marks? 4. And that's your 4 marks. Here's your 4 marks. 1, 2, 3, 4. This is your 4 marks. You just write this. But you need to write it based on what happens to R. What did we say will happen to R? R will what? We said R will increase. So all I need to do is to come here and say, if R what? Increases, please don't write R, you have to write resistance. Total current will what? Decrease. V internal will what? Decrease. And V external will what? Increase. This is my explanation. So I know it will what? Increase. And then 9.2.4 revive. I was going to say that. Now, I was going to say this question is negative marking. Because if your 9.2.3 is wrong, we don't even read 9.2.4. That's why, if you notice what I did now, I answered my 9.24 first, then I went back to write my 9.2.3. It's called negative marking. Because you are telling me a wrong answer, why must I read your reason for wrong answer? No. We say this is white, you say it's black. Now you want to justify that it's white when the answer is black. There's no need. No, there's no need for me to it creases. Unfortunately, you have to put the suffix this time. Guys, did it make sense? And that's your 4 marks there. So your answer, most questions, I can tell you that 80% of the questions in electricity in grade 12 will have this as my final question, revive. I'm not saying all, but most. So just remember, oh, it's revive. I am using the revive principle. Resistance, current, V internal and V external. Guys, are you okay so far? Are we okay? All right. So we are going to use graphs to then explain, so we know we are done with this. Electromagnetism, I need to do that in one lesson and compress the whole thing. That one is very, very simple. where you talk about your magnet moving. That's very, very straightforward. One lesson. The thumb rule, Faraday's law. We're going to compress that in one lesson. This is more impactful. Okay. All right, guys. That's it. And you may actually... somebody's laughing and happy because we are done. Yes?
So I wasn't here for yesterday's lesson. Please will you send the link on the group?
Okay.
I mean, not yesterday's lesson, I mean last week's lesson. Sorry, sir.
All right. I'm just using a playlist, so I'm just going to... I think I did drop the playlist. I'm not
For
sure.
maths, sir.
I dropped for maths. Okay, I'll drop the one for
Yes.
physics.
Yes, please drop the physics one.
Okay.
Okay. Thank you very much, sir. Enjoy your night.
You too. Bye.
Bye, sir. Thank you.